The broadcast is now starting. All attendees are in listen-only mode.
Are you able to see my screen?
Yes, ma'am.
Okay, very good. Good morning, everyone. I'm Srividya Bansal. I'm faculty in the software engineering program at Arizona State University. And today, in this webinar, we're going to talk about software engineering tools and processes. So I'll turn off the webcam and I'll focus on the slides that you should be able to see now. At any point during the presentation, if you have questions, feel free to write in the chat window and I will try as much as possible to watch it. So this session today is basically an introduction to a short week-long course that I'm planning to have in India during summer, July. So this will serve as an introduction to what to expect in that week-long course. So basically, the focus here is on teaching software engineering tools and processes across the entire software engineering life cycle. And I'm going to be using a hands-on learning experience. So today I'll introduce a new pedagogical model called the software enterprise, which we use here at Arizona State University in our software engineering program. So that's. So I'll start with what is engineering. Let's start with that definition because I think that will help us in better understanding what tools and processes we need. So basically, engineering is general engineering is the systematic application of existing scientific knowledge. It's basically using that existing scientific knowledge in creating new solutions, and we want to create these solutions to solve some practical problems, and we want to create the solutions in such a way that they are cost effective. So basically that's the general definition of engineering. Now, then let's think about what is software engineering. So basically, you can think of software engineering as a problem-solving activity. So basically, it comprises of two tasks. There is analysis and synthesis. So basically, in the analysis part, we try to understand the nature of the problem that we have at hand, and then we break that problem into pieces, into smaller pieces. And then our goal is to find solution to those smaller pieces, and then put those pieces together to synthesize and form the larger structure of whatever we are trying to build. So basically, it's a problem-solving activity. So let me pause here, and I want to know a little bit about the audience here. So I have a poll here. If you can please use your either your computers or your mobile phones and go to this link, pollev.com/se tools. So if you go to this link, you should see a question. So basically, the question is, are you involved in teaching any software engineering course? So yes or no. If you can please answer. The link again is pollev.com/se tools. So I'm trying to understand how many of you in the audience are familiar with or are involved in teaching software engineering. And looks like Sridhar has posted the URL in the chat window as well, in case you want to copy it from there. So I'm just waiting to see more responses. Then I'm also trying to see how many have answered so that I get a sense for. So far I see 100%, but let me go to the poll to see how many. Well, that's only one response, looks like. I'll give it a few more minutes. If you're facing any issues in answering the poll, you can feel free to write in the chat window. Okay, so far I got only 2 responses. It looks like both of them have said that they do teach software engineering course. So I'll move on, and you can feel free to continue if you're not able to get to the link while I'm talking. If you're able to get to it, you can feel free to continue and answer. So basically, for those of you who have taught these courses, you might be more familiar and might understand better what I'm talking about. But then for the others, it's still general enough so that you see what the pedagogical model is, and at a high level, you'll probably understand the tools, because I'm mainly only giving an overview today. So more specifically in software engineering, in order to do this problem solving, what we really are using are techniques. So techniques are basically methods or formal procedures using some that produce certain results, and using some well-defined notation. So to give you an example of a technique or a method would be like, say for example, recursion is a technique or a method. There is a well-defined mathematical notation for it, and you're able to produce, you're able to use this formal procedure and produce certain results. And then there's methodologies, which is basically nothing but a collection of a number of these techniques that are applied across software development, and they have some kind of a unified philosophical approach. So to give you an example of a methodology, object-oriented programming is a methodology which comprises of a number of different techniques. The techniques could be things like overloading, overriding methods, um, inheritance. So in all of these techniques and methods together forms the object-oriented programming methodology. And then finally, what we need are tools. Tools are basically the instruments or the automated systems or the software that's going to help us accomplish a particular technique. So our tools could be things like our IDE, Eclipse, NetBeans. These are integrated development environments, the language itself, and any other software tools that basically facilitate the creation of the methods and the methodologies are what are tools. And for software engineering, we need all of these 3 things. So to formally define it, software engineering is basically a collection of these techniques, methodologies, and tools that help with the production of high quality software system. And while we're producing the software system, we have to make sure that we're within a given budget, as well as we have to make sure that we produce the software within the given deadline that's set forth by the client. And we need to do all of this while change occurs. This software world deals with continuous changes. The changes are in terms of, it's a fast changing world wherein the requirements can change. There's a lot of flexibility software offers. So requirements change, techniques, tools change, and the frameworks and languages available keep changing. So while all of these change occurs, we still need to keep up and produce high quality software. So basically in this course, what we're focusing on are these tools and processes that can be used in order to produce a high quality software system. We are assuming that the techniques and methodologies, which is basically the programming languages and the different programming paradigms, are something that our students or audience is already familiar with. Now we want to give them the tool set with which they can be effective software engineers. So here's my second poll question. If you can go back to pollev.com/SE tools, and I'll quickly post the second question over there. All right, I have just activated the question. So basically, what are some important characteristics of a good software engineering course? And this is for those of you who have taught the course, and even for the others who might have some familiarity with this domain. What do you think are some important characteristics of a software engineering course? And you can type in your responses in the text box, and you can type in multiple words or phrases as well. And as you start typing in, we will see the word cloud over here. Okay, that's very good. So we're getting some answers now. So let's look at the word cloud. What we see is quality assurance, analysis, planning, and there's more coming up. Risks, efficiency. Well, maybe this was a sentence that didn't get broken up appropriately. You're right. Planning and is definitely important. Addressing quality in software development is very important. So some of these reusability is another good one. Efficiency, you see how the efficiency is in bold, so it looks like a number of you think that efficiency is an important characteristic. Cost, I see a few other ones there that are important. So whenever we are dealing with software development, all of these aspects are important, and therefore when we're teaching software engineering, we need to introduce all of these aspects in the course. Now, another interesting one that I see is iteration. Software development has very much become an iterative process now. Unlike a decade ago, maybe, now everyone uses agile methodologies and follow iterative processes in software development, and we will address that as well in the course when we talk about various processes. So that's great. Thank you for your responses, and we'll go back to the slide deck. So at this point, I'll stop and talk a little bit about the pedagogical model that we use and that I plan to use for this course. It's called the Software Enterprise, which we've been using for the last 8 years since the inception of our software engineering program at ASU. So basically, the way in fact, our program and any software engineering program, the belief is that we want to produce engineers who are industry ready. So the key thing is industry readiness. So once they graduate from these programs, students are able to right away are able to produce software and help teams in making progress towards their goals. So with that in mind, some of the characteristics that we have focused on. Typically, software engineering is heavily team-oriented work. So we have a multiple sequence of software engineering courses, with each of them focusing on a different aspect, like say, be it requirements or tools and processes, or software testing and quality, or software project management, software construction. So we have a sequence of these courses that the students take, and all of them are process oriented, in the sense that all of them involve teams and they involve problem solving. And the problems should be such that they are large and complex enough that needs the students to actually leverage these tools and processes. Because if it's a trivial problem, then the tools and processes might not make much sense, and they may not see the point. And that's not what the industry does. The industry typically has large and complex problems that they're working on. And the students are then exposed to these different practices that are typically followed in the industry as well, and they're presented in a sequence, and they progress through that sequence. So basically, it's a multi-semester or multiple years of repetition and sequencing and variability. So we're following the same, using the same tools and processes, and following the same pedagogical model across multiple semesters. And then we also make sure that we bring in projects that are real world, so they're actually exposed to what they are likely to see in the industry in the future. And then it's very collaborative in nature, which means students learn these, they have to learn that one of the key component in software engineering is people. It's the people that they're going to work with, and it's very important that they learn how to work with people. So the short course that I'm designing will also follow all of these, will use all of these aspects, and every day of the course will basically follow this repeated process that's collaborative in nature, addresses real world problems, and exposes to the latest tools and processes that the industry uses. So then we'll talk about projects. Projects are very important in software engineering. It doesn't help to just learn what tools and processes are there. One has to apply it in a real world context. So and that's what entails good software engineering. So that's what basically provides hands-on learning experience. It provides students with problem solving exercises. And then projects also involve mentoring. When students work in teams, there's scope for mentoring each other while they're solving these complex problems and trying to come up with a scalable solution. So with that said, the software enterprise model that we use, it's basically inspired in the, we can always go back to educational literature and what theory is it inspired from. So basically it uses Cobb's experiential learning cycle model, which was published in 1984. And what that involves is, so there is an abstract, so in general, for any learning cycle, this model is applicable. There is an abstract conceptualization that we're trying to learn or teach. And we want to make sure that this concept is learned or concluded through experience, rather than just listening to someone tell you. So that's the idea of experiential learning. So there is an abstract conceptualization, and then through active experimentation, that is planning and trying out something that you have learned, through that the students gain concrete experience. So we're going from an abstract conceptualization, do some experiments, try out something hands-on, and then gain concrete experience with it, and then reflect on the experience that is gained. So reflection is also an important aspect in software engineering, is what we've noticed, and it is also done a lot in the industry. So it's important to review and think about the experience, what was good about the experience, and what was not so good, what could have been done better. So every time an experiment is done and some experience is gained, it's important to reflect over the observations that were obtained. And then you go back into the cycle with the next abstract conceptualization and do the same thing. Do some hands-on experimentation, gain concrete experience, and then reflect upon it. So basically, we use this this experiential COPE's learning cycle model, and we use what's called the software enterprise model that one of our faculty members at ASU, he came up with, and he calls it the software enterprise model. So basically, in here, for each module that needs to be taught in the class, the idea is you start with preparation. So we have preparation here at the top. We start with preparation where students and faculty, they assess on what's available. So, and then, so this could mean coming prepared to class even prior to the lecture. Maybe there's some kind of a reading that's posted prior to the lecture that students go through and come into the lecture and are ready for a discussion. So preparation followed by discussion. So that's our presenting the abstract conceptualization. Then comes practice or competency. So this is where the students are actually now practicing what they learned through some sort of exercises, experiments, or some kind of hands-on activity. And then once that practice is done and they've gained some experience, now we want students to reflect on that experience once the practice is completed. So this is post-practice. And then they reflect about what were the strengths, what were the weaknesses, what is it that they liked about it, what is it that they did not like about it. Then once that's done, the next step is now to learn further about that same concept in a real world context. So we want to contextualize it now with some real world problem, and then they apply that same concept in that real world problem. So this could be in the form of a project, a running project throughout the course, and now they apply this particular concept to that project. And then once the project, that particular part of the project is complete, so post-project, again, another reflection activity happens as to how do they feel about the concept learned and the experience gained. Do they feel confident now, or is there still some aspects that need more clarification, and so on. So basically, the purpose of doing this reflection every time is to think about what can we do better. And then you go back into the cycle of preparation, discussion again with the next module. So basically for every module, we want to do this. We start with preparation and lecture and discussion, then do practice through some hands-on activity or a lab activity, then reflect on the experience, then apply that knowledge in the form of in a certain context in the form of a project, and then reflect again on that experience. So typically when it's a semester-long course, each module can be run in the form of a sprint. Now, for those of you familiar with the word sprints from agile software engineering practices, wherein sprints are these fixed time periods during which there are some set goals and the team tries to achieve those set goals. So we run the course also as sprints, and the length of the sprint can be determined based on the module that's being taught. In a typical semester-long course, the sprint can be 2 weeks or 3 weeks. But then it can be as short as 1 day. For example, for the week-long short course that I'm planning, we'll have daily sprints wherein every day a new concept is introduced. It's practiced, and then there's contextualized learning in the form of a project, and then reflection activities are done at the end. So every day would be a sprint. So let's go back to the poll one more time, the same link, polleb.com/se-tools. I'll post the next question there. Name a few software engineering activities. So basically, software engineering is, we said, a problem-solving activity, basically. Now, how do you break up the different activities within it? Given a problem, if you have to build a solution to it, a software solution, what are the typical activities that one uses in the software engineering world? Okay, analysis, requirement analysis, perfect. That's the first activity, typically, always. What else? Right, very good. So we have design, there's planning, then there's construction or coding or construction. Then there's testing and validation, very good. And then there's, so I see analysis, requirements gathering, all of that would come under the same thing. After that, there's design or modeling. And then there's planning can come in anywhere in there. It could be at the beginning as well. And then you have coding and construction or development. And then we have testing and validation. And then we have deployment. And communication, of course, has to happen throughout the project. So that's great. And again, within testing, there's different types of testing. There's alpha and beta. So I see some of you have entered that. So that's great. So all of these are typical software engineering activities. And when we talk about tools, so basically we are now looking at what are the tools available to facilitate each of these activities for us. So let's go back to the slides. So so just like you listed, you see, we have design, modeling, coding. Now, even before design, actually, there is requirement analysis, like some of you had posted in the word cloud. So we have design, modeling, coding, testing, configuration management, and build management. So this short course is basically going to focus on all of these activities, and it'll introduce the tools and techniques that are needed specifically for these activities. So that's what we will be doing. Now again, let's go back to the poll, and I have another question there for you. Advance this. So the question this time is, name a few course activities or teaching methods that you commonly use in software engineering courses. So here I'm more interested in hearing what kind of teaching methods do you use to teach software design or software construction or programming for that matter. What specific teaching methods? So case study, that's a very good one that is used a lot. I see pair learning, very good. Yeah, pair learning or pair programming. Hybrid learning. I'm assuming when you say hybrid, maybe it's a mix of in-class and some kind of online activities. I see zigzag. I'm not sure what that is. I'm not familiar with that. I see TDD. That's interesting. Test-driven development. So that can be used where you start by everything by testing first and then adding code to the test cases. Project. You see project and presentations. Yes, that's a typical traditional style of teaching where you have presentations of some sort, like I'm doing here, or as a projects that's definitely needed in software engineering. So that's good. So I see a number of different kinds of teaching methods here. So let me exit full screen. No, so some of the methods that we will be using for this short course is, and based on the software enterprise pedagogical model, we'll have readings. So there'll be pre-assigned readings and possibly even a quiz based on that reading to ensure that students have actually read or gone through that reading before coming into the lecture. Then we'll have our traditional lectures, but then the lecture, we want to keep the lectures short, short to introduce the abstract conceptualization and allow the students to then practice through hands-on exercises. So once the lecture is done, then some kind of a short exercise to try out the concept. A lab activity, again, short exercise and or lab activity, followed by a project incorporation. So now you're incorporating that concept into your project, and followed by reflection. So these will be the course activities that we will be using. Here's my next question. Name a few tools that you introduce in software engineering courses. So what kind of software tools are you introducing to your students in software engineering courses? And if you have multiple software engineering courses, it could be tools catering to different aspects of software engineering. Visual paradigm, yeah, okay. Rational rows. I think the cloud is kind of messing it up a little bit, but I see what you're saying. I do, it makes sense. The rational rows, a UML tool, Umbrello, another UML tool, visual paradigm for modeling as well. I see Estimate Pro. I'm not sure if that's if I broke it up correctly. OOMDP, I'm not familiar with that one. DevOps, okay. Cool. So I see a lot of a lot of focus on modeling here. So a lot of modeling tools, and we will also be looking at a modeling tool. In fact, today I'm going to introduce one. And at the end of the day, whatever tool works for you is good. The idea here is to basically provide that tool set to our students so they're familiar with what's available for different aspects, what's available for modeling, what's available for testing, what's available for build management, what's available for release management, and so on. So going back to the slides. So today I'll give a quick introduction to one particular kind of UML diagram. So we'll talk about UML quickly for those of you who are not familiar with that. UML stands for Unified Modeling Language. So basically it's a notation. It's a notation for modeling so that any designs that we come up with, there is a consistent notation that one can look at and understand, as well as that notation can then be translated into some basic skeleton code in a language of your choice. So it is a non-proprietary standard, and again, with some history about UML, the way it came about was through convergence of multiple notations that are used in object-oriented methodology. So there's a OMT by James Rumbog and his colleagues, and a BOOP method, and OSC method by Ivor Jacobson. It's a convergence of all of these notations. And you can find more information at uml.org. So there are a number of different tools. Oops, sorry. There are a number of different tools for UML. Rational, like one of you had entered. There's a Together, Visual Architect, Asta. Asta is the one that I'm going to show today, and that's the one that we've been using more recently. We've used the other ones before. I've used Argo UML before, Star UML also, Umbrello, as one of you mentioned. Now, so if I'm introducing this concept of UML, typically in a class, there would be a reading assigned prior to the lecture, and that reading can be a chapter of the textbook, or it can be a public paper, or it could be an online resource. So in this case, the reading is the 5th chapter of, say, the software engineering book. So a quick overview of some of the important UML diagrams that are typically used is, and this is only 20% of UML. So there's two categories. There's use case diagrams and class diagrams. Basically, the purpose of these is to model the static behavior of a software system. And then the sequence diagrams, state charts, and activity diagrams that basically model the dynamic behavior of a software system. So there is a specific purpose, there's a specific design aspect that each of these diagrams are capturing. So use case diagrams, for example, the purpose is to describe the functional behavior of the system. So there we are thinking about what is the functionality that a software system provides. Again, this is from a user perspective, and then that functional behavior is described. Class diagrams, on the other hand, they describe the structure of the system, the static structure. What are the different objects in the software system? What are their attributes, and how are they interacting with each other? What are the associations between these objects? So class diagrams is from a programmer perspective. Use case diagram is thought about from a user perspective. When the user interacts with the software system, what is it that they're interacting with? Sequence diagrams, it basically describes dynamic behavior between different objects in the system. State chart models the dynamic behavior of an individual object. So we take one particular object and think of the different states that it can be in, and what kind of stimuli or triggers cause it to change from one state to another. So this is state charts are specifically used for any complex object within the software system that has a lot of dynamic behavior. And activity diagrams, on the other hand, is also dynamic behavior, is to describe the dynamic behavior of a system, but it's more with a focus on the workflow within a software system or a subsystem. So the focus is on coming up with that workflow. So now, when we do modeling for software systems, we choose what is appropriate. Don't have to create all possible UML diagrams. We choose whatever makes sense. So typically use case and class diagrams are always done because they define the functionality and the structure. And then the dynamic, depending on how dynamic the software system is, the other ones are chosen. So today we'll focus specifically on UML state diagrams and what it means, and we'll look at a few examples. And again, to remind you, I'm going to use that experiential learning model, a software enterprise pedagogical model, wherein the first part is a preparation. So the students come and prepare through a pre-assigned reading, and maybe they even complete the quiz before coming into the class. Now, let's assume that's over. The next step is the lecture or the discussion in the class. And more specifically, we want to discuss what is this behavior modeling? How do state machines or state diagrams look like? What are the different components in the state chart? What are different types of events? And then what are the differences between activity and state diagrams? Because both of them are modeling dynamic behavior. So basically, like I said before, the purpose of a state diagram is the focus is on one individual object and thinking of all of the different states that this object can be in, and what are some of the external and internal events that this object is reacting to. So typically, when you have a real-time system, that's when you're likely to have those kind of objects. And then the diagram itself, the notation is basically using nodes as states, And then the events or the triggers or the stimuli are basically edges or arcs drawn between nodes. And I'll show you an example in a bit. Half power anytime, and then there's a set time state wherein you're trying to set the time on the microwave. So pressing the timer button will take it into a set time state, and as long as you're clicking on the number, it still remains on the set time state. Now from there, if the door is open or door is closed, based on that, the oven goes into a disabled or enabled state. So basically the idea is that you're thinking of all possible triggers or stimuli that can happen with this object, and what happens when those stimuli occur, and what are those different states, and how are those state changes happening. That's the kind of information that we are trying to capture over here. So from an enabled state, if you press the start button, that's when the microwave begins operation. It starts doing the heating job. While it is in operation, if the door is open, then it goes into a disabled state and it displays waiting over there. And from that disabled state, it will not go into the enabled state until the door is closed. So those are the kinds. So here, and this is important in a software system, because when you're modeling software and when you're for a particular object, you have to think of all of these possibilities and think of what needs to happen with all of these different triggers. And like I said, there's always a start and an end state, and sometimes, like in this case, both the start and the end states are actually the same. It's that waiting state. We've just repeated it here on the right hand side for clarity in the diagram. So basically, it's this states and stimuli. So like you saw, the different states of this object were, say, waiting, half power, full power, disabled, enabled. All of these were the states. And then the arcs represented the triggers, like pressing the start button or opening the door or closing the door. Those were the stimuli for the microwave oven. Now here's another example. Let me actually quickly see how I'm doing the time. Oh, okay. Here's another example, and here we're talking about a PhD candidate, a student who is working towards his or her PhD degree. And again, we have the start state here, where the student starts with taking classes. Only when they pass all of the classes, then they're able to take the qualifying exams. Only when they pass the qualifying exam, they begin to write their literature survey. When that's done, then they go through a candidacy exam. When they pass the candidacy exam, that's when they can do they can defend their topic. Now, at any point from these stages, if they fail, or if they decide to quit after writing the survey, the student is fed up and doesn't want to continue anymore. So that's when they quit, and you see all of these arrows are pointing to an end state. So that's where the life of this object ends. And then from topic defense, you're going to all but dissertation. Now this, you see that interesting thing over here is you have a state and you have sub-states within it. So all but dissertation is where only writing of the dissertation and the final defense is left. So those are the sub-states within this larger state. And then once the final defense is completed, that's when you reach the end state. So again, just here's another example to show what are the different states and the stimuli in this case. So now so that was the introduction to the abstract conceptualization of state charts. The next thing is to now try out an exercise, hands-on, so the students are able to think through this concept and apply it in a certain given situation. So here's an exercise. Think about a state diagram, the different states and the stimuli, basically that models the behavior of an LCD display of a simple watch. So the figure here shows a simple watch which has an LCD display displaying the hour, minutes, and seconds. And then there are two push buttons, 1 and 2, that are used to set the time. So basically the way it works is pressing 1 will toggle the hours button. So the hours on the LCD display. And then pressing 2 will basically increment that number. Now, when the hour is toggling, if you press 1 again, then it'll go to toggle the minutes. And if you press 1 again, it'll go on to toggle the seconds. And whichever one, sorry, not toggle, blink. Whichever, so you're pressing 1 to basically select which one you want to blink, the hour or the minute or the second. And whichever one is blinking, in that state, if you press the button 2, then the number will get incremented. So that's how you're able to set time. And then when you're satisfied with the time that's there on the display, that is, you're done setting it, then you press both the buttons together to finalize the time. So basically that's the functionality of this state diagram. Because we're running short on time, I'll go ahead and show the solution, but in a typical class would allow the students to try this out and provide some guidance as they are trying it out, and based on the questions that come up, we help the students with it and then discuss the solution. So the solution is that the different states are that either the hours are blinking or the minutes part is blinking or the seconds is blinking. The way we get to blink hours is when the button 1 is pressed. And now from that state, if button 1 is pressed again, you go to blink minutes. From that state, if button 1 is pressed again, you go to blink seconds. From any of these states, if button 2 is pressed, then that will result in incrementing the hours or the minutes or the seconds. And then when both buttons are pressed together, then the blinking stops and the time gets set and you reach the end state. So that's a solution for that exercise. So there's our initial state, our final state. Those are our different events and transitions. And then the nodes itself are the states. So thereby, basically the purpose of the state diagrams are to model, represent this dynamic behavior of a single object. We don't do this for every object in the software system. You do it for particularly complex and interesting objects that are harder to model and understand. So let me stop there quickly and let's go back to the poll. Okay, and let me advance the question. So here's the question. What tools have you used for, sorry, let me activate. What tools have you used for modeling? So I know that in the last question, some of you did enter Umbrello and rational rows and visual paradigms. I see star UML now, so it looks like some of you are using that, rational rows. Okay, very good. Any others? Okay, Microsoft Visio, yeah, you can use Microsoft Visio too. That's good. So that's good. And one of the tools that we use is called Asta. I wanted to do a demonstration. It's actually fairly straightforward. I'll quickly show. It's like any other modeling tool wherein you can click on the project, click on the diagram, click on the specific diagram that you're interested in, like say state machine diagram, which is what we're talking about. Here's our start state. There's an end state, and then you can create from the start state. I've created a new state, and then I can give it a name. So the exercise that we saw was blink hours, so I can basically put that, and then I can put the transitions between the nodes and create the diagram. In a similar manner, other diagrams also can be created with it. So the next important thing to talk about is the reflection that I had mentioned. Every time, so you gain experience and then you reflect on it. So typically we ask students, do you think this technique was useful? Would it be useful on real software projects? Will it benefit in your class project? How will it or how will it not? And in general, what do you think some of the main benefits were, and what were some of the challenges? So this reflection then helps in basically understanding the process and understanding how students can do better. Once that's done, then we get into the contextualized learning, wherein now you want to apply this concept of, say, we went over state charts. Now we want to apply it in the context of a project. Say the project is there's a game that the students have to build during the entire course. So they're going to specifically do some modeling for that game with a focus on state charts. So they'll identify a particularly complex object with a lot of dynamic behavior and create a state chart for it. So basically, that's where we are now putting it into context and using it in the project, and then we do a post-project reflection again, wherein again it's the same questions are revisited, but now more specifically how their experience was in applying it to the project. So that basically completes the software enterprise cycle, the pedagogical cycle, like in case of the experiential learning cycle. And different pedagogical variations can still be applied. Like, if the lecture, if one wants to use flip classroom, they can make the lectures available beforehand and have just a discussion in the class to further reinforce the concepts. Online delivery of some of the modules can be done. Mastery-based learning, hybrid learning, all of these other kinds of learning can still be applied within this model. The goal here is we want to learn by doing and learn in context, in real world context. And we're doing that by first preparing, discussing, practicing, and then applying it in a project. So that's the idea. So like I mentioned, this week-long short course, some of the logistics will have daily sprints because it's only a week-long course. Before the day starts, there will be a reading assigned, and maybe with a quiz to make sure that the reading was completed. The morning session will consist of a lecture and discussion, and then a late morning session will include some kind of a practice, some exercises using or a lab activity, and then that will follow a reflection. And then the afternoon session will consist of doing it in the context of a project and again reflect upon it. So at the end of the week, basically we'll conclude with a completed project and a demonstration of that project and a reflection of that process. So like I said, typically when you do a semester-long course, each sprint is 2 to 3 weeks long, but here I want to make it daily sprints for that short course. So let me see how I'm doing with time. I think we do have a few minutes for question and answers. So I basically wanted to give you an overview and show what to expect, and show you the hands-on learning pedagogical model. And we use the concept, the abstract conceptualization that we used today was state diagrams or state charts. I'll open it up for questions. So you can feel free to type your questions in the chat window, and I will answer them. Also, because we only have a few minutes, if you don't get a chance to ask a question, you can please feel free to send an email to srividya.bansal@asu.edu. So I see there's a hand up. I'm not sure. Sridhar will have to help me here. Do I give control to any of the attendees who have questions?
No, they can send their questions by the text chat window.
Okay, in the chat window. If you can please type your questions in the chat window, I will read it out and try to answer it. And like I said, if you have, you can feel free to write to me as well, and I'm happy to answer any other questions. In general, about the software enterprise model and how we run it here at ASU, or specifically if you're interested in the short course that we're planning to offer in summer in India, then that's I'm happy to answer any of those.
Can you see the question?
Oh, sorry, I'm seeing some questions here. I was looking at the wrong window.
Oh,
So the first question is about is asking about research areas in software engineering. So there's a number of different research aspects in here. There's a lot of research going on in software design and how to design patterns and how to come up with better design patterns. There's extensive research happening in validation, software verification and validation, applied in the context of safety critical systems. And then there's also a lot of research happening in, just because software engineering can be applied to any application area. So it can be software engineering for AI applications, software engineering for building big data systems. It can be software engineering for building some kind of medical systems or health informatics systems. So there's a lot of research, and then there's mobile computing, and that's software engineering too. So there's a lot of research happening. It could be applied research, where it's about how to apply some of these techniques and processes for a specific application, or it could be core software engineering research on, say, requirements, how to do requirements analysis better, or how to do software design better. So those are some of the different research areas, in short. And I'll be happy to further discuss that with you over email. You can feel free to write to me. The second question is how to evaluate the progress daily, as we do in Scrum. Yeah, so basically that happens through that reflection process. So the instructors are basically looking at the student reflections and then trying to address any issues that come up there. And here we're talking about student outcomes and are they learning or not. So there's also grading happening, right? The grading of these different activities, completion first of all of the in-class activities and the project. Are they able to complete it or not? So those are the kind of things we do. And then assessing projects and assessing team projects in itself is a research area as well, because it's not so straightforward. So typically, so we get into those different assessment techniques there. Yeah, to evaluate progress daily, basically maybe the simplest thing would be to look for completion, whether students are participating and are able to complete their assigned tasks or not. Now here's another question on which are project management tools for Gantt chart, PERT chart. So there are a number of project management tools these days that will kind of take care of or have all of these together. Like you want to deal with organizations, you want to deal with scheduling, you want to deal with the resources available. So there are tools like Tiger. There's a number of Scrum-based tools that will help help manage projects, and one can decide how much they want to do through these tools. So I plan to introduce a project management tool as well. We've used in the past one called Scrumwise. We use Taiga, and there are many more. There are more smaller, lightweight tools for a specific purpose. So we see that as well. Now, can we apply machine learning in requirements elicitation? Now, that's a slightly harder question, and we have seen that we have capstone projects where a lot of projects are machine learning related projects, and it gets a little hard to apply these software processes there, because machine learning involves a lot of times coming up with the model and fine tuning the model. So basically, but then even with machine learning, we've been using agile, with the agile software engineering processes. We've been using Scrum for those as well, and have had some success. Basically, the idea is it's more research oriented. So here, every sprint, they have to define what are the research questions, what kind of fine tuning are they doing, what's the data, what's the training data, what's the test data, how are they fine tuning the parameters. So those are the kind of things that the sprint would focus on. It's not the typical software development activity. Now, another question is if you could provide more detail about how the course will be offered, timing and instructors. So I'm assuming here this question is about the summer course that I was talking about. It will be an in-person course, and I will be doing it myself. I'm planning to visit India in July, and depending on where we are able to set it up, we will set it up as a week-long course in one location, and I will be there delivering, doing the instruction. So that's the plan so far. We're still trying to gauge interest and see how many are interested, and Dr. Krishna Vedula will have more details on that for you. Is machine learning techniques can be used in software testing? So I'm not sure what that means. In order to test, so that's I can totally imagine that being a research area that the community is exploring, trying to test data, trying to test software using previous data and machine learning techniques. I must say I don't know top of my head if there's any existing techniques already. I need to look that up. But it is very well possible with now that machine learning is being applied to pretty much anything and everything. So it's very well possible that people are trying to do software testing using that. Though there's a lot of it needs to be thought through. Does it even make sense to do that? Asta, practical software engineering concepts. Asta, is it open source tool? So I'm trying to answer those questions that I can quickly. So Asta is not an open source tool, but then they do have an educational license. I was able to get a free license as a student. So students are able to get free license, but it's only for a short period of time. Educational institutions can get an educational site license. And that's and I believe that's much cheaper than the regular. So it's not a completely free software. So you can explore the academic license basically. Please suggest a delivery method. So delivery method again, I think it cannot be one. It'll have to be a mix of things like short lectures followed by these lab activities, and that's what I plan to do for the short course. Basically it will be, and that's what we do here at ASU. Short lectures followed by exercises and lab activities, and then followed by project. So we mix all of these up together to deliver each module. So that's what we've been doing. Okay, that's good. So I think I got through quickly got through all of the questions, but if you're, I'm sorry if I did it in a hurried manner. If you're not satisfied, if you want to further follow up, please feel free to email me and I'll be happy to answer the questions. All right, so with that, I think because it's already beyond the pre-assigned time, I'll stop at that. You have a wonderful day, and my email address is here, srividya.bansal@asu.edu. Thank you.
Thank you.